Okay, we're going to get started with this video. This is about how you take an STL file and get it printed. So we're going to pick up from where we left off on the previous video where I showed you how to get a CT or an MRI segmented out, do some design on it, and turn it into a model. So we were left with anterior and posterior vertebral bodies with uh, dowels sticking out from the posterior elements and holes in the anterior elements. And we exported the STL files to the desktop. So we got 4 different parts. Now I'm going to use Cura. We have an Ultimaker 2 printer, and Cura is the software that comes with that. Just I would keep Cura updated also. They're constantly coming out with updates, and you know, problems you may have had in the past will be fixed in the latest update. So always a good idea. So once Cura is loaded, we want to load a model file, and we save them to the desktop. And so we have all these different models that we want to print out. I believe we can just select all of them. And this will take a bit. There we go. So it loads it on, and this is kind of a simulation of the bed that you're going to print on. And at this point, you want to kind of think about how it's going to print out. So if you've never done 3D printing before, the Ultimaker 2 is a fused deposition modeling type printer where it's basically going to lay down layers of plastic one at a time. Now you can see here, as it's positioned now, this dowel is just sort of hanging in midair, and so it's going to have to print support material underneath everything that's just hanging in free space. So the first thing I usually do is try to position everything so that you minimize the amount of support material that's going to be printed. And so within Cura, you have the ability to rotate objects. And I think this is going to make it pretty slow. So why don't we just load them. We'll just act like we're going to print out the L3 level. Okay. So this is our vertebral body anterior element with the holes in the back. Now what I want to do is have these facing up so that support material isn't printed inside of that hole. So I'm going to rotate it so that it's facing up. Like that. And I think it'll be able to print the hole without any support material inside of it and make it so that those cylinders can slide in there nicely. And so that was L3 anterior. We're going to load up the posterior STL file. And you could debate what the best way to print this would be. I'm going to print them with the dowels facing up, and so I'm going to rotate this also. Okay. And again, it's the same click shortcuts to rotate in Cura. I'm right-clicking right now so that I can rotate the screen around. Those are kind of tools that take a little bit of time to get used to. So you can see here that the cylinders aren't really facing up. So now they're facing straight up. You're still going to have to print support material for all the transverse processes. You're going to print a lot of support material. You can't really avoid that. And so now they're positioned on the bed plate. And if we look at the basic options within Cura, the Ultimaker 2 can print at 0.1 millimeter thickness, so that's a very high quality print. If you increase your thickness, that will decrease the print time and it will look a little more rough. But you know, not every model has to look perfect, so it's possible that you might want to increase the layer thickness. The shell thickness of the outside shell in the horizontal direction, I actually bumped this up a little bit from what I had been printing at initially, just to kind of make the model a little more solid. I thought it made it look better. Bottom top thickness, I make the same as my shell thickness. Fill density, how densely filled the inside of a print will be. Print speed, a well-adjusted Ultimaker can reach 150 millimeters per second, so I went to 50. So if we think about support types then, got some different options for that. Right now everywhere is selected. You can see that there are other options, none and touching build plate, and everywhere is going to put it even on top parts of the model, so touching build plate makes the most sense in this case. And then finally you have your support type, and you can do a brim or a raft, and highlight over the tooltip here. Raft is basically thicker. A brim is one layer and a raft is a thicker object. It does say the brim is the recommended option. That hasn't worked very well for me in the past. I've had problems with the model sort of falling off of that single layer and have had less print failures with the raft. So that's what I've been using. And then we have a 0.4 millimeter nozzle on our Ultimaker printer. There's some other advanced options that I honestly haven't played with very much, and so this is basically what I've tweaked to get models printed the way I want. I'm sure that there are probably better ways to do it, and I'm definitely open to suggestions as well. Once you have your print configured the way you want, you'll see here it displays how long it's going to take to print and how much material it's going to use. And the time estimate is usually pretty accurate. It does take a long time to print stuff. This, anterior and posterior elements for one vertebral level is going to be 8 hours and 15 minutes. You can see here it's going to use 5.6 meters of material, or 44 grams. If you look at the type of filament that's available, say a PLA filament, about $60 for a filament that is 0.75 kilograms. So that's 750 grams. So this was going to use 44 grams. So it's using about 6% of a spool. So 0.06 times $60 for a filament means that these anterior and posterior vertebral bodies are going to cost about $3.50 to print out. And so if you print out 2 vertebral levels, it's about $7. And then if you print out a thecal sac that's considerably smaller, let's say that costs another $1. This model is going to cost roughly less than $10 to print out. So not too bad. So once you have your model configured the way you want to, at least for an Ultimaker, save a G-code file. And you can save that anywhere and put that onto an SD card, pop it in your printer, select it, and away you go. So that's how you get a model ready to print using Cura.